Welcome back to your statistics course. For this lesson on central tendency, I'll decorate the slides with artwork by Piet Mondrian. Recall, my purpose for using abstract art is to show how we can distill an image or an idea down to its essence and express it elegantly. For example, this image depicts taxicabs in New York City in an abstract way. Can you visualize the taxicabs in this image? I construct lines and color, combinations on a flat surface, in order to express general beauty with the utmost awareness. I want to come as close as possible to the truth and abstract everything from that until I reach the foundation of things. This is a quote from Piet Mondrian. He was part of an artistic movement called neoplasticism. Some of the main ideas were abstraction, simplicity, and minimalism, distilling objects down to their basic forms. We lose information about an object when we reduce it to a simple form, but we can also gain information about the object by getting to its essence. It all depends on whether we have a good process for reaching the simple form. When we summarize a set of numbers with an index of central tendency, we lose information by deleting details, but we also gain information if we have a good process for summarizing the details in a way that captures the essence of the full set of numbers. We're beginning Chapter 4 on measures of central tendency. Chapters 4 through 6 cover important ways of describing data characteristics. Chapter 4 will focus on central tendency. Chapter 5 will focus on variability and dispersion. Chapter 6 will focus on shape. The topics for Chapter 4 are, first, Chapter 4.1, Mode, Median, and Mean, which we'll cover today. The next chapter will be summation notation, and then linear transformations. Then we'll talk about other properties of the mean, and some closing thoughts. We're going to be talking about 3 ways of measuring central tendency: mode, median, and mean. We'll talk about definitions, process, symbols, and limitations. The definition of the mode is the most frequently occurring score. The process of finding it is simply by eyeballing the data. That means doing a visual inspection. And the symbol for the mode is capital M, lowercase o. The headings on the table are as follows. X equals the score for a group of people. F stands for the frequency, which is the number of people who received that score. So we can see here that the scores range from 0 to 10, and the frequency of a score of 10 is 1 person. The frequency of a score of 9 is 3 people. Frequency of a score of 8 is 5 people, and so on, down to the frequency of a score of 0 is 4 people. 6 is the score with the highest frequency of 11. There are 6 people who received a score of 11, so 6 is the mode, or the modal score for the data set. With this kind of distribution, the mode of 6 is a useful index of central tendency. There are scores above and below 6, but 6 is about the center or the middle of the data set. Here again, the headings are X, which is the score for a group of people, and F, or frequency for the number of people who received a given score. This distribution is called bimodal because two different numbers, 8 and 2, appear 20 times in the dataset. No number appears more than 20 times in the dataset. Is there a way to summarize the mode with just one number? Can we take the mean of the two modal values by adding them together and dividing by 2 to compute a single mode of 5? There isn't really a convention for handling this question. 5 appears to be a better index for central tendency, but there are only 4 people with this score. A choice of 5 doesn't match the definition of mode, which is the most frequently occurring score. This kind of distribution underscores one of the limitations of using the mode as an index of central tendency. We can see that neither 8 nor 2 is a good index of the center of the distribution. There isn't really a precise way to pick a single mode. I would report both 8 and 2, identifying the distribution as a bimodal one. But the two modes don't tell us where the center of the dataset lies. Here's another distribution that shows us a limitation of using the mode as an index of central tendency. Technically, the mode is 8, because 20 people got this score, and it is the score that appears most frequently in the distribution. But it is useful to point out that the score of 2 is also relatively common compared to the other scores that occur quite a bit less often than 8 or 2. Should we compute a weighted average of 2 and 8 for the mode? Should we report both 8 and 2 as the modes? Here again we have a conundrum. The weighted average does not match the definition of mode. Reporting 2 and 8 does not give a good index of the center of the data. I would report the distribution as bimodal, but that isn't completely satisfying either. Here is yet another distribution that underscores the limitation of the mode as an index of central tendency. 10 is clearly the mode for the dataset, but it's not near the center of the data. The mode for these data isn't very helpful as an index of central tendency. Here are two different distributions with two different modes. 6 for the dataset on the left, and 9 for the dataset on the right. Suppose we want to combine the distributions. Is there an easy way to compute the mode of the combined distribution? Can we take the average of the two modes and report that? No, we can't do that. The mode is a non-algebraic statistic, meaning that we can't use a streamlined method to compute a mode with combined distributions. Instead, we have to take it step by step, and for each x value, add up the frequencies in the two distributions. This is yet another limitation of the mode. When we combine the distributions step by step, we find the mode for the new distribution is 3. A fairly satisfying choice for the center of the distribution. Next, we'll look at the median as an index of central tendency. The definition is it is a score that bisects the distribution. The process, it can be found by counting or by using a formula, and the symbol is uppercase M, lowercase d. How can we find the median by counting? We find it by using the following information. We look at the sample size, which is 11 in this case. Case 6 is the middle case. There are 5 cases with scores higher, and there are 5 cases with scores lower. Case 6 has a score of 7, so the median equals 7. How can we find the median by using a formula? Let's consider the following distribution. Consider the following assumption. Assume that people with any whole number score, for example 5, are uniformly distributed across the interval from 4.5 to 5.5. 4.5 to 5.5 are called the boundaries or real limits of the observed score of 5. We're summarizing and simplifying all scores between 4 and 5, 4.5 and 5.5 by labeling them as 5. We are taking continuous scores and simplifying them as discrete whole number scores. Here are the symbols we need to compute the formula for the median. Uppercase L sub uppercase m is the lower limit of the median's interval. Lowercase w is the interval's width. Lowercase n is the sample size. Lowercase f sub cum is the cumulative frequency of the interval below the median's interval. And lowercase f uppercase sub m is the frequency of the median's interval. The median is equal to the lower limit of the median's interval plus w, which is the width of the interval, times the quantity of n, which is the sample size, divided by 2 minus f sub cum, which is the cumulative frequency of the interval below the median's interval, all divided by f sub m, the frequency of the median's interval. This looks and sounds like a lot of number crunching, but if we break it all down with an example, you'll see it's very manageable. With this data set, you can easily find the median by the counting method. By definition, the median will put 25 people above it and 25 people below it. By inspecting the cumulative frequencies, we reason that the median must lie between 4.5 and 5.5. And to show you that the formula gives a more precise answer, let's crunch the numbers. The median's interval lies between 4.5 and 5.5. So the lower limit of the median's interval is 4.5. The interval width, w, is 1. The sample size, n, is 50. And the frequency of the median's interval, f sub m, is 9. And the cumulative frequency of the interval below the median's interval, f sub cum, is 19. When we plug all these numbers into the formula, we find the following. Remember from your past work in algebra that we perform the operations inside the parentheses first, so we compute 50 divided by 2 minus 19, all divided by 9. We multiply this quantity by 1 and add 4.5. The result is 5.17. Suppose we have two data sets. What is the median of the combined distributions? We see with the data set on the left, the x values range from 0 to 10, and we can see the frequencies for each score in the column with the heading of f. The median of this data set is 5.17. The data set on the right also has values that range from 0 to 10, and we can see the frequencies of each score under the column with the heading of f. The median of this data set is 4.83. Now, suppose we have the two data sets. How do we find the median of the combined distributions? The only way to do it is to add the frequencies for each score together and use the counting or formula methods on the new distribution. We can't make the job easier by combining the medians of the original two distributions. A mathematical way of saying this is the median is non-algebraic. When we do the operations, we find that the median is equal to 5.08. Now we turn our attention to the mean. The definition is as follows. It is the simple arithmetic average of a set of numbers. The process is to add the scores up and divide by the number of scores, which is the sample size. The symbol for the mean is x over bar. An example showing how to compute the mean for a set of scores is as follows. The process is we add up the scores to get total of 35, divide by the sample size, 5, and the mean is 35 divided by 5 equals 7. A key term is outlier. An outlier is an extreme, wild, rogue data point. A robust statistic is a statistic whose value is not impacted by outliers. Are the mean and median both robust to outliers? The median and the mean give us the same value for the center of these data. And for this data set, it might appear that the mean and median are both robust. So case 1 has a value of 4, case 2 has a value of 5, and case 3 has a value of 6. So the mean and the median are both the same. They're both equal to 5. But the median is robust and the mean is not robust to outliers. As we can see, the median for these three numbers is 5, but the mean is 203. So we can see that the median is robust to outliers. It's not at all affected by the outlier, which is 600. In contrast, the mean is affected in a big way. The mean is not robust to outliers. So in sum, we learned the mode is the most frequently occurring score. The median is the middle of the distribution, found either by counting or by formula, and it is a robust statistic. The mean is the arithmetic average, and it is not a robust statistic. Next up, in our Chapter 4 lessons on measures of central tendency, is 4.2. We'll be covering summation notation.